In this video, we are going to look at the units converter, but with a different approach. And this is called behavior-driven development. And I'll provide a little bit of an orientation on what behavior-driven development means let's take a look at this diagram. Let me expand it a little bit. What you'll see is that we're going to specify and verify the Fahrenheit to Celsius conversion formula. What we're going to do is take a similar approach to the test-driven development, except what BDD does is it allows you to specify the feature in a language that is more human readable, and that is kept in the feature file. So in order to do our BDD, we're going to use a tool called behave, and that's described in the README. The README will explain how to create a Python virtual environment, how to activate that environment, how to install behave, and then I'm going to pick up from confirming that behave version is installed. So let me open the terminal window. And here I'm going to just run behave -- version. And we see that I have version 1.2.6 installed. So from there, we're going to talk a little bit about the framework itself. So the framework is going to use this behave.ini file, and we'll see that there's a path called features. This is where all the feature files will be located in this project. And there's only one feature file, and so if I go to that features folder and open it, this is what that features file looks like. So the way behave works is that it will process this structured format. And there are three essential elements. There's the given, the when, and the then. So the given is very much like the arrange. The when is very much like the act. And the then is very much like an assert. And so we already have behave set up to run. So let me clear the terminal and run behave. And let me expand that so you can see what happened. The first line it started to process was given I have a temperature converter. Then it tried when I convert 32 degrees Fahrenheit to Celsius. And then it encountered a problem. It described this problem. And what we'll see in the last line here is that it's got a not implemented error. So when we actually read what happened, one step passed, which was that given. So we were able to arrange. Then one failed, which was the when, which means that the action failed. And then one skipped, which means that it didn't try the next line. So going back to the logic, so the given passed, the when failed, and the then was skipped. So now let's take a look at this code. So the way the behave works is that it associates this English language specification to a Python code. And the Python code connects. So let's close the others. And let's put the feature flag side by side. So that you can see it. And what you'll see is that in the feature flag, this given statement is associated with this given tag. So given I have a temperature converter, so it associates that string, I have a temperature converter, with this step. The next one is when I convert Fahrenheit to Celsius. So when I convert Fahrenheit to Celsius. And then the last one is the then clause. And that was skipped. So that is how our step works. I'm just going to go to my code here and see, well, how is our source conversion working? And our source conversion is not implemented. So this is why it failed. So let's put these files back on one. So what I'd like to do is, instead of having it not do that, I'd like it to pass. So I'm going to do a return. Oh, we see that it's starting to get smart again here. So what I want to do is just return 0. But I'd also like to turn this off for just a minute. So let's snooze the completion, get it to stop doing that. So Copilot is getting ahead of us. So now when I run behave, what we'll see is that that test passes. There's a way to run behave so that it will stop at its first error. And I would like to add that in here. So it's -- stop. So that will just stop if there's an error. Okay, let's split things out again. And I'm going to put the code on the right and start my next test. So here in my feature, I want to add a new test, and that test will be when this is 212. Right? Let me turn the Copilot back on and see how that might be able to help me write my next test. I'm going to unsnooze that and then try writing this test. Right away, it gives me the 212 option because it figures that's a good next test, and I will accept that. And now when I run behave, it will stop because it encountered that error. And you'll see it ran the first one just fine. It fails on the second one. So I will add a little bit of logic here that says if Fahrenheit is equal to 212, then what I want to do is return 100. What I'm doing in BDD is very similar to what I do in test-driven development, is I just write enough code to make sure that that test passes. And I can do a little bit of cleanup work. We see our code is helping us, or our Copilot is helping us tidy a little bit. Okay, the next one that I want to write, it's suggesting 98.6 would return 37. That's the human body temperature. That looks good to me. I'll go ahead and save that. Try to run it. Now this error looks different than the one we had before. It says the statement, when I convert 98.6 degrees Fahrenheit to Celsius, is not found in that second statement. The reason is because it doesn't support the type. So when I look at it, I'll see that Fahrenheit is a is a decimal, and that is a float. So what I can do here is I can say at when, and what it will do is suggest that float. I can go ahead and accept it. And now when I run it, it's now going to tell me that 37 degrees failed as a scenario. So I can go back and I can say else if Fahrenheit, it's 98.6, 98.6, and that should return 37. Now that behavior has been added. So now the next feature I want to add is, let's say, minus 40. So minus 40. This is same in both scales, but I want to kind of note that a little bit differently. It's where the linear scales intersect. And that's what I want to know. Okay. And now when I run behave, it's going to give me that error. That's not handled. But I can quickly add this scenario and make that test pass. One thing's nice about behave is that because these scenarios can be parameterized, I can come up with all kinds of new additions here. This one is a great example of a test where I like the input and the output, but I don't like the reason. So this might be better explained as potential divide by 0. And that's the reason I want to test that scenario. I run behave again, and this time it tells me I'm missing a step. And again, the negative number with a decimal point is a clue that somehow it's not accepting that. And here I see that with the then floating point is not being handled. So I add that and run it again. And now it failed because when Fahrenheit 0 comes in, I don't get that result. So I can do another else if Fahrenheit. No, it's not 0 that I want to. Yes, correct. It's 0 with the minus 17.78. Run behave again, and that passes. Now I'm going to switch it up just a little bit and add a new scenario. This scenario is when we try and convert temperature below absolute 0. So here we have a temperature converter, just like we had before. Now when we convert minus 500 degrees Fahrenheit to Celsius, like we do, then we should not be getting this number. What we should be getting is a error raised. So what we want is value error should be raised. Now when we run that, we're going to find that, nope, there's no step. when it's raised. Okay, well, that makes sense. There's a missing step. We add that, and now it's going to make a suggestion here. And that suggestion is we're going to look and check that. What I want to show you is that this suggestion is not quite what we want. It's hard-coded the minus 500, but more importantly, this is the act. And we don't want the act to be within the then, right? We want the then to be the assertion. So what I'm going to do in order to get this to pass, well, first of all, let's see how this runs. And it will say the scenario did not happen correctly because the value should be raised. Didn't happen correctly. So what we actually want to have happen is that the conversion should fail. So what we'd like to do is we'd like to try and change this a little bit. So I like the code, it's just in the wrong place. So we'll move the code up here. And we'll make this happen. So what it's going to do is it's going to try to throw the exception. And now what we're going to see is that everything else started to get into trouble. Well, that's not correct. So let's see if we can't, in our context, know if the value error was raised. Okay. And here, all we really care about is whether the value was raised. And then down here, all we really care about is asserting that it was raised. And we'll try and run that. See that ran through everything. And now it's failing for the correct reason. The exception was not raised. Now let's go in and put our logic that basically says, please raise that value error if it's below our absolute 0. And now it passes. Okay, one final test we want to put in here is what happens when we're at exactly absolute 0. So that's minus 459.68. It suggests exactly the right answer. We run the test. And it fails. So at this point, it might be a good idea to add that one scenario in there. Okay. It is still failing. It passes everything except the last one. Let's expected Celsius should be minus oh, okay, let's see. Context Celsius. It is trying to do the conversion. Okay, if it's less than 6.7. So we've got a little bit of a typo here. So it turns out that it gave me the wrong absolute zero. It's 6.7 that I should be looking for. So now I found the error thanks to BDD. And there is the correct answer. Okay, so it looks like all the scenarios are being tested. If I go back and look at my diagram, um, it is these scenarios and everything is passing. At this point, I'd like to refactor. So what I'm going to do is I'm going to use the conversion formula, which has us going from Celsius to Fahrenheit. Okay. And then we want to return Celsius. So now we save this and try run it. And now we've got an error. So the error is that we're not rounding to 2 decimal places. So we could add that here where we round Celsius to 2 decimal places. Once we save that, and now we know our truth table has been fully satisfied. We look through that, and all of those scenarios are passing, and we have our error handling also taking place.